So in this lesson, chapter 4, we're going to go back and readdress a topic from chapter 2. And that topic is functions. And we talked about functions in chapter 2, as well as chapter 3. We know something's a function if for every time I stick a value in for x, I get exactly one answer. Now, there's different ways we can illustrate whether something's a function or not. One way is called a mapping, which is being shown here on the video. And also, this is not in your handout, but this is the first one. So for 2, I get one answer, which is 1, 4, 7, 11. Each of those get exactly one answer. So this would be an example of a function. If I wanted to do the inverse of the given function, that means that 1 would go back to 2, 5 would go back to 4 since 4 goes to 5, 11 would go back to 7 for the same reason since 7 goes to 11, and 19 would go back to 11. So in the inverse, the 1, 5, 11, and 19 would be x value, where x was 2, 4, 7, 11 in the original. And also the 2, 4, 7, and 11 would be the y values as 1, 5, 11, 19 was in the original function. We can also write these as ordered pairs. So in the original function, the ordered pairs would be 2, 1, 4, 5, 7, 11, 11, 19. And in the inverse, it would be 1, 2, 5, 4, 11, 7, and 19, 11. So in your handout, what I'd like you to do is, I would like you to draw the inverse mappings for each of these. Decide based on the inverse mapping which of these are functions, and then ask you to circle them. When you're finished, turn your video back on. So in the first one, every x value, probably first with the x, second with the y, every x value goes to exactly one answer. So the original mapping is a function. And that would be also true for the second problem as well as the third problem. Now the third one, it looks like it would be a no because the y value is always 15. But each x value is going to one number. It just so happens that it's 15. So these are all yeses for the original. So for the inverse mapping, the numbers would be 11, 13, and 15. And then those numbers are going to 3, 5, 6, and 9. So 11 goes to 3. The 13 goes to the 5 and the 6, because originally the 5 and 6 went to 13. And then the 15 goes to the 9. This would not be a function because the 13 is give me two different answers, 5 and 6. In the second one, the numbers that will be non-com x, that will be 9, 13, 21, and 30. And those numbers would be going to the 2, 3, 11, and 13. So 9 goes to 2, that's 2 went to 9. 13 goes to 3, 21 goes to 11, and 30 goes to 13. This would be a yes. Each x value goes exactly one y value. And the last one, the x value would be 15, and the y value would be negative 3, 0, 5, and 11. And then this one here, the 15, is actually going to each of these numbers because originally each of these numbers, which are now the y values, went to the 15. This also would be a no because 15 has 4 different answers. The bottom of the handout asks you to write the table that would be the inverse of the original table, and then decide whether or not this table is a function. Go ahead and do that. Turn the video back on when you are ready. So the inverse of this table, all of the y values or f of x values now become the x values. other side becomes our inverse values, or y values, for graphing them. This would not be a function because the 20 is giving us two different answers, 16 and 20. So this is no because we don't have a one-to-one mapping for 20. So we looked at table, we looked at a mapping, I've mentioned order pairs. Here what they're asking you to do is write the inverse of each of these relationships and our relations and decide based on the inverse is it also a function. So these are just 4 points, and some of these may not actually, the original ones may actually not be a function to begin with. So the first one, the 12, the 14, 15, and -3, the x values only show up once. So this original one is an example of function. The question is the inverse. So we go ahead and map out the inverse of each of these, and then decide on each of them, the original and the inverse, which ones are yeses, which ones are no's, and then turn the video back on when you're ready to continue. So as mentioned, this first one is a yes because each x value always shows up one time. If I would write the inverse, the 12, 15 becomes 15, 12, 18, 14, -3, 15, and 13, -3. And this also would be a yes because, again, each x value, 15, 18, -3, and 13, only show up once. In the second problem, 9, 16, 0, -3, this is an example of a function. And then if I would do the inverse, becomes 11, 9, 19, 16, 9, 0, and 11, -3. And this one would be a no, because the 11, as an x value, shows up twice. The last one, the original is a no, because the 11 shows up 4 times. So I mean, the 11 has 4 different answers, so it's not a function. If I would do the inverse of this, it would be 111, 18, 11, -3, 11, and 13, 11. And this one here would be a yes, because the 1, the 18, the -3, and the 13 all have exactly one answer. Again, just because the y is the same number, that only means that the line or the points which are creating a line is a horizontal line. There's no slope to it, so you keep getting the same answer over and over and over again. But it's still a function. All right, so here they're asking you to create the table for the original and then create the table for the inverse, and then ask you to write the equation. So if you go ahead and do this, turn the video back on when you are ready to continue. All right, so since the y-intercept is 6 and the slope is 3, that means it's going to increase by 3 each time. And so the answer before that would be a decrease by 3. So this would be the original table. If I would do the inverse, all the y values are now x's. So -1, 3 becomes 3, -1, 0, 6 becomes 6, 0, and so on. So for each x value, it's only shown up once. So again, it is an example of a function. And then ask for an equation. So what we're missing is the b value. So I'm going to use a table instead of an equation here. So the b value would be -2. So if I go back to x being 0, it's the b value. And the slope, as I'm increasing the x by 3, the y is increasing by 1 each time. So the top number is the run, the bottom number is the rise. So again, slope is rise over run. So the slope is 1/3, where up here, the first table, the slope was, again, this is the run, which is 1, and the rise, which is 3. The slope here is 3 over 1. So they're reciprocals of each other. So the equation would be y is equal to 1/3 x plus -2, or y equals 1/3 x minus 2. So starting here, they're asking you to now graph the inverse of each given function, and then decide based on the equation or the graph, is it a function or not. So go ahead and do the first one, and then turn the video back on and make sure you're on the right track, and then from there you'll go ahead and finish the rest of them. Alright, so if I was going to graph the given points, so I'm working with the inverse function, so 3, 3 would still say 3, 3. 2, 1 would become 1, 2. 1, -1 would become -1, 1. 0, -3 would become -3, 0. And -1, -5 would become -5, -1. You'll notice that these 5 points appear to be linear. And keep in mind, this line here has millions and millions of points on it. We're just only graphing 5 of them. So if I was to graph every single point that's on that line as its inverse, it would also produce a line. So the inverse of this graph is also a line. So the answer is yes, it's an inverse. So you have, I think, 4 additional ones. You have a line, parabola, another parabola, and a cubic function. So if you go ahead and complete these, turn the video back on when you're ready to check your answers. Alright, so for the next one, I went ahead and completed them, so to save some time. The next one is a function. Again, the line's inverse is another line, which is in red. All we did is I took the order of pairs and then switched the x and the y. The third one is not a function because it does fail our vertical line test from chapter 2. So if I draw in an equation at x equals 5, there are 2 answers for 5, 2 and -2, so this one's a no. This one also is a no because, if I draw in a vertical line at -2, again, it fails the vertical line test because there's 2 answers at -2, so this again is a no. And then the last one is a yes. It does work for every x value. There's exactly 1 y answer. All right, so the rest of the handout on the last page is a series of problems, and that will be in the next video. There will be a Grassel math activity that I'll be going through with you, and you will also need to open up the link to the Desmos graphing calculator, which is provided in your It's Learning account. That will go that last set of problems as well. So please turn this video off, go back to It's Learning, and turn on or click on the second video.